In 1609, Kepler published his first two laws pertaining to planetary motion. It focuses that the movement of the planet Mars, its observed motions, and any proposed models of the solar system didn't match that involved solar orbits.
On his previous law, it is stated that Mars travel in elliptical orbit with the Sun at one focus of the ellipse. Kepler only came to this after figuring out his second law.
Kepler's laws apply. First law, planetary orbits are elliptical with the Sun at a focus. Second law, radius vector from the Sun to a planet sweeps equal areas in equal times. Third law, the ratio of the square of the period of revolution and the cube of the same ellipse, semi-major axis is the same for all planets.
An imaginary line drawn from the Sun to the center of the planet will sweep out equal intervals areas of time. This is what we call the second law of Kepler's, the law of area.
Kepler's second law, sometimes referred to as the law of radius, describes the speed at which any given planet will move while within the Sun. The speed at which any planet moves through space is constantly changing.
A planet moves fastest when it is closest to the Sun and slowest when it is farthest to the Sun. Yet, if an imaginary line down from the center of the planet to the center of the Sun, the line would sweep out the same area in equal period of time.
For instance, if an imaginary line were drawn from the Earth to the Sun, then the area swept out by the line in every 31-day month will be the same. This is depicted in the diagram below.
As we observe in the diagram, the areas formed when the Earth is closest to the Sun that can be as wide but short triangle, whereas the areas formed when the Earth is farthest from the Sun that can be approximated as narrow but long triangle.
These areas are the same size since the base of this triangle are shortest when the Earth is farthest from the Sun. The Earth would have to be moving more slowly in order for these imaginary areas to be the same size as when the Earth is closest to the Sun.
Mars travels in an elliptical orbit, and that speed varies so that the Mars-Sun line sweeps out in equal areas and in equal time. Were generalized to include all planets in 1621. The second law is also a consequence of the conservation of angular momentum.
Angular momentum is a measure of the amount of rotational motion in a body system of bodies like Mars and Sun. And in the absence of outside forces, it speaks a quantity, which implies a trade-off between the distance at which Mars orbits and its velocity. Angular momentum of Sun and planet is constant.
Kepler's three laws of planetary motion can be described as the follows. The path of the planets about the Sun is elliptical shape, with the center of the Sun being located on one of the poles. The ratio of the square of the periods of any two planets is equal to the ratio of cubes of their average distance from the Sun.